Good morning, class. Today we're going to discuss the enthalpy of reaction and some problems involving enthalpy reaction. So to find delta H for a reaction, we have to measure the Q. When we study energy changes in chemical reactions, the most important quantity is usually the enthalpy of a reaction, which is denoted by delta H reaction. The change in enthalpy that occurs during a reaction, such as the dissolution of a piece of copper in nitric acid, and if heat flows from a system to its surroundings, the enthalpy of the system decreases, so delta H reaction is negative. Conversely, if heat flows from the system or from the surroundings to the system, the enthalpy of the system increases, so delta H of the reaction is positive. Thus, delta reaction or delta H reaction is 0 for an endothermic reaction. In a chemical reaction, bond breaking requires an input of energy and is therefore an endothermic process, where bond making releases energy, which is an exothermic process. So, bond breaking is an endothermic process because it requires an input of energy, while bond making is an exothermic process because it releases energy. The sign conventions for heat flow and enthalpy changes are for the reaction type, exothermic, that is greater than 0. So the heat flows from a system to its surroundings, and endothermic is the heat flows from the surroundings to a system. So exothermic is negative and endothermic is positive. If delta H reaction is negative, the enthalpy of the products is less than the enthalpy of the reaction. That is, an exothermic reaction is energetically downhill. Conversely, if a delta reaction, H reaction, is positive, then the enthalpy of the products is greater than the enthalpy of the reactants. Thus, an endothermic reaction is energetically uphill. Two important characteristics of enthalpy and changes in enthalpy are summarized in the following discussion. Bond breaking always requires an input of energy, and bond making always releases energy. I repeat, bond breaking always requires an input of energy, while bond making always releases energy. The enthalpy of reaction changes in, or the energy in changes in chemical reactions are usually measured. So as changes in enthalpy, if heat flows from a system to its surroundings, the enthalpy of the system decreases. Delta H reaction is negative, and the reaction is exothermic. It is energetically downhill. Conversely, if heat flows from the surroundings to a system, the enthalpy of the system increases. Delta H reaction is positive, and the reaction is endothermic. It is energetically uphill. So let's solve this problem example. Problem number 1. How many joules are required to heat 15.2 grams of water at 35 degrees Celsius to 70 degrees Celsius? So in order to be able to determine how much heat is required to increase the temperature of your sample of water from 35 degrees Celsius to 70 degrees Celsius, you need to know the value of water specific heat. So as you know, a substance specific heat tells you how much heat is required to increase the temperature of 1.0 grams of that substance by 1 degree Celsius. Water has a specific heat of about 4.18 joules per grams per degree Celsius. This tells you that in order to increase the temperature of 1 gram of water by 1 degree Celsius, you need to provide it with 4.18 joules of heat. Therefore, in order to increase the temperature of 4.18 grams of water by 1 degree Celsius, you would need 4.18 times more heat than water's specific heat value. Also, in order to increase the temperature of 4.18 gram of water by 4.18 degrees Celsius, you will need 4 times 18 times 4 times 18 times more heat than water's specific heat value. The problem above wants you to increase 15.2 grams of water by 35 degrees Celsius. So this means that you will be needing 15.2 times 30 times more heat than water's specific heat value. Mathematically, this is expressed as Q, which is the specific heat, that is equal to M times C times delta T, where Q is the heat absorbed, the mass of the sample is C, absorbed in the mass of the sample. C is the specific heat of the substance. Q delta T is the change in temperature and defined as the final temperature minus initial temperature. Again, if we try to go back, Q is equal to M times C times delta T. So the heat enthalpy, which is Q, is equal to the mass times the specific heat times the change in the temperature, which is final temperature minus initial temperature. So to substitute the equation with the given values, the enthalpy Q is equal to 15.2 grams times 4.18 joule per grams per degree Celsius times 70.0 minus 35 degrees Celsius. We have 2223.76 joule. So that's it. Thank you for watching and listening. Have a safe and happy learning to all of you.